Good evening, friends. So, hope you understood yesterday limit x tends to 0, sin x by x is equal to 1, that theorem. What I am planning today is I will work out a few sums that I have taken from the NCERT 11th and 12th standard books based on the limits and continuity chapter. And then we will wind up this chapter. Afterwards, we'll go to the differentiation side. So, let us begin the some of the worked examples, some sums, whatever are there. I'll just share with you. So all are important only, but these sums will actually summarize this chapter for us one way. It will be beneficial also for all of us. So let us start. Let us say they have given a sum of this kind. Prove that or show that limit x tends to infinity, x cube plus x square plus 4x plus 5 divided by x cube minus x square plus 5x plus 6 is equal to 1. So this sum they have given, asking us to do this. Let us say straight substitution you put. Actually infinity unmeasurable. You cannot put directly infinity here. Infinity cube plus infinity square plus 4 infinity. Again infinity only. Infinity plus 5 is also infinity only. So finally you end up numerator also infinity, denominator also infinity. Totally it will be a kind of wrongdoing. It should not be done. So answer is not infinity. So they themselves said that one you prove this. That means there is a method to do this. Let us see how to solve this problem. From the numerator, you take out x cube common. What you will get here? X cube by x cube. I am writing for your benefit. Plus x square by x cube plus 4x by x cube plus 5 divided by x cube. Denominator, take out x cube common. X cube by x cube minus x square by x cube plus 5x by x cube plus 6 by x cube. First you cancel this and this. Here you don't forget. Keep writing down x tends to infinity. So numerator side, x cube and x cube we can cancel. X square, it will go here one time. X will go in x cube, x square times. Equally in the denominator, x cube get cancelled. And here this will become 1. And x will go in x cube, x square times. And this remains so. So what you are left with now after all this cancellation, limit x tends to infinity, 1 plus 1 by x plus 4 by x square plus 5 divided by 1 minus 1 by x plus 5 by x square plus 6 by x cube. Okay. See here what I am trying to do. Infinity, as I told you, we should not substitute directly. Therefore, we have to take substitution here. Put 1 by x is equal to y. Put 1 by x is equal to y. As x tends to infinity, 1 over infinity becomes 0. That means y will tend to 0. If x is tending to 0, y will become 0. So after all transformation of the limit and then substitution, you will have here limit y tends to 0, 1 plus y. See 1 by x becomes now y. 4 by x square becomes 4y square. This will become 5y cube divided by 1 minus y plus 5y square plus 6y cube. Now straight away you can put y 0 wherever y is 0. 0 you can substitute 1 plus 0 plus 4 into 0 0 plus 0 divided by 1 minus 0 plus 0 plus 0. So now finally it has become 1 by 1. That means 1. So we have proved the sum. Hence proved. So what we did here, we just did transformation. Instead of directly putting infinity and then saying that it is indeterminable, what we did, we have started telling it first take out common and then substitution, changing the limit from infinity to 0 and then substituted. So hope you followed this sum. This is one of the sums what I found in the limits chapter. More or less all the limits tending to infinity will be like these transformations only. It won't be any difficult at all. Any doubts are there, you can just post me. Let us go to another important sum. Say for example, I am having second sum I am doing. F of x is equal to 2x plus 3. F of x is equal to 2x plus 3. Check the continuity at x is equal to 1. Check the continuity at x is equal to 1. Means what? If you put 1 in this equation, is it becoming infinity? Or is it becoming 0 by 0 kind, indeterminate kind of thing? No. So straight away, let us put this f of 1 here. What happens? Put x is equal to 1. Then f of 1 is equal to 2 into 1 plus 3. That means 2 into 1 is called 2 plus 3, 5. So f of x is now existing. So f of x is continuous now here. So there is no issue here. Even if you come from 1 minus, for example, limit x tends to 1 minus 2x plus 3 and limit x tends to 1 plus 2x plus 3. Even if we do this, answer will become same because they both will tend to 3 only, 5 only. So you can try out. In previous sums we have done this by taking x and y. We started taking the limit very close to 1. Below 1 we have started telling that 0.9 onwards we can take and then substitute the value of y, how much it will come like. So 2 into 1.8 become roughly 4.8. So you can continue further and further. So take down all the values 0.009. These are all minus signs. Similarly, you do for the x tends to 1 plus and then fill the table. Here x, here y. So my here plus side you take now. X tends to 1 plus. X tends to 1 plus. That means what I am doing, I am approaching the 1 from both left side and right side. From this side and from this side. Here also same limits I am taking like 0.9 like that. Here also you go with plus 0.9 onwards. You come down. Same way you go 0.09, 0.009. Same values will come. Here also plus 4.8 will come and continue further. Both the values, if you observe, they tend to 5 only. So the limit x tends to 1, 2x plus 3 will become equal to 5. So the tendency of this number, finally you will be finding 4.999 like that. Here also you'll see this. That means 4.999 is equal to 5 only. Straight away you can tell. So f of x, that is directly when you put f of 1, it became 5. When you went in this coordinate system kind of thing, that also is tending towards the 5. So you can conclude here that f of x is equal to 5 and continuous. Why? Because your LHL is equal to RHL. This side is called left hand side limit. This is called RHL limit. What is meant by y here? Y is nothing but your equation f of x. F of x is equal to 2x plus 3 for you. So wherever x is there, these values 2 into 0.9, 2 into 0.9, that we substitute and then get the final answer. It will be terminating to finally 5. Here also same. So all the LHL is equal to RHL is equal to function value. Therefore, the function given function is continuous at x is equal to 1. Okay. This is how we checked continuity in previous slides to check up. So next sum. Next sum is they have given you one modulus function, I think. Yeah, correct. F of x is equal to mod x. They're asking us to check the continuity. Check continuity at x is equal to 0. So we should know what is the definition of this mod x. Mod x we know very well. Mod x is equal to minus of x as long as x is less than 0 plus x as long as x is greater than or equal to 0. That means the value of this f of x will vary minus x to plus x like. That means even if you substitute x value a negative number less than 0, still it will give me positive value only. That's why mod of anything is positive. So let us check this continuity first. Let us say I am going towards the negative side. Limit x tends to 0 minus f of x. Come to the equation here. What is the equation? When x tends to 0, I should take minus x. So that means I should write here limit x tends to 0 minus x. Let us see here. Minus x means what? Let us say, for example, I will take minus 1. X value minus 1 if I take. What is my definition? They are giving top. Function is minus x. That means minus of minus 1. That will become plus 1. So this value for minus 1 plus 1. If you substitute, let us say minus 2, then it will become plus 2 because minus into minus plus 2. So for all negative numbers, because of this minus sign present here, that minus and this minus multiplying together and making the value positive. So for all values of x below 0, you will be always getting same x. Let us say take for example plus sign. 0 plus means I am approaching from right side. I am approaching the limit from right side now. Then here also limit x tends to 0 plus. What they gave me, 0 plus means greater than 0. So I have to write here x. So here also, whatever value you define now, let us say 1 I defined. Then I'll be getting 1 only according to this equation. F of x will give me x. So this is also x. So if you substitute negative value also, you are getting positive response, positive value. Then positive value putting also negative. That means both LHL and RHL are giving me same value, that is 1 or f of x. So that is why this function is continuous at x is equal to 0. Straight substitution also is giving me f of 0. For example, if I directly put f of 0, it is equal to x they are telling, so 0. If you put 0, it is 0. If you put 1, it is 1. So at 0, f of x is equal to 0 from both sides, from limit 0 minus and limit 0 plus. From both sides, the value is equal to 0. That is why this function is also continuous. So modulus function is continuous now at x is equal to 0. Okay, let us go to another sum. Show that, they are telling, show that f of x is not continuous. Show that f of x is not continuous at x is equal to 0. So we have to see what is the sum now. What is f of x they have given here? F of x they said x cube plus 3 as long as x is not equal to 0, whereas it is 1 whenever it is 0. So they themselves defined at f of x, when x is equal to 0, they defined that at x is equal to 0, f of 0 is equal to 1. So remember this first equation for us. Now let us check the function at 0 right from left hand side. Limit x tends to limit x tends to 0 minus f of x. 0 minus means less than 0. X is not equal to 0. That means any value, either negative or positive. It is not defined that less than 0 or anything. They said less than 0 means x cube plus 3 I should take. Limit x tends to 0 minus x cube plus 3. Here, this value becomes 3. Let us say I have taken x tends to 0 plus. 0 plus means what? It is not equal to 0 plus means above 0. Above 0 means not equal to 0, that is. Not is equal to 0, this is above 0. So that means what I should take? I should take 1 here. Understanding, no? Here please carefully observe. 0 minus and 0 plus. That means one is below 0, another is above 0. Above 0 means I should take x not equal to 0 equation. That is x cube plus 3. Sorry, not equal to 0 means any equation, this only. 0 means only 1. That is the only one. Like for example, see here. This I will rewrite again and tell you. Yeah. Suppose if you take x, limit x tends to 0 plus f of x is equal to limit x tends to 0 plus x cube plus 3. So this will become again for me 3 only. So here what is happening for me? RHL and LHL both are equal. LHL is equal to RHL. Both are equal to 3. But function value f of 0 is not 3, it is 1. Therefore, f of x is not continuous at x is equal to 0. Understanding? No? So clearly see. Whenever function is not equal to 0, they said it is equal to x cube plus 3. Whenever it is 0, it is equal to 1. So when you are approaching, when you are taking the limits from left hand side and right hand side, you must use this equation. When x is equal to 0, we should take this numerical value 1. Since all three are not same, function is discontinuous. So hope you followed this. So hi friends, let us do the last sum in this limits and continuity chapter. That is, discuss the continuity of 1 by x function. Okay. So let us do this sum. I remember having done in the earlier videos. Please go and cross check. But however, I'll try to repeat this. Discuss the continuity of f of x is equal to 1 over x. Okay. And x is not equal to 0. This is the main point. We know if x becomes equal to 0, what happens? The function tends to infinity. So we'll check this function now thoroughly. Let us say, for example, limit x tends to any value you take, c. F of x will become 1 over c. Correct? We will take set of values x and fx and study the value of f of x with respect to the inputs, that is with respect to the x now. How do? We will take 0 because they said 0 here. We'll check the problem at 0, what happens really like from left hand side and from right hand side. or RHL, LHL. I will show you from RHL point. You can work out in a similar manner LHL also. So let us start from, let us say 1. I will take x input 1. Then what will happen? Y? 1 by x. That will become 1. Next, if you x you take, for example, 0.3, means we are approaching towards 0 now. So f of x will become 1 by 0.3. That means 3.33. By fx becomes what? 3.33. Now you take 0.2. This will become 5. You take, let us say 0.1. 0.1 means 1 over 10. That is 10 to the power of minus 1. If you take 0.1, fx will become 1 by 0.1. That means it will become 10. If you take 0.01, then this is called 100. This is also called 10 to the power of minus 2. You take 0.001. This will become minus 3. So here it will become 1000. Okay. So that means if we observe very clearly, the x, that is independent variable, as it is approaching towards 0, the f of x is increasing enormously. It became 1000. Now let us say I have put another input. If you write here 10 to the power of minus, let us say n will be very, very, very small, infinitesimally small, 0.00001 like that. Then this f of x will also become 10 to the power of n. Followed. That means this value keeps on increasing enormously as it approaches 0. The other way around is telling this function will tend to infinity as you approach 0. So if you draw the graph, I am drawing like this. This is 1. Let us say this is 0. This is f of x and this is x. So now we studied the response between 1 and 0 because our target is to see that what happens to this curve as you approach towards 0. So I began from RHL, right hand limit side. That is 1 plus like. So from here when I did, if you see as the 1 is coming closer and closer to 0, the y value is enormously increasing. We're observing, no? Slowly it is initially small, but it increased. It will go up to infinity. Equally, this side also, if you do it at home, this will be like this. Same way, this will be like this. Curve shapes will be almost same. Like this. Now, what does it mean? It means that at 0, the function doesn't exist. It will go to infinity. Whereas all other values which are not equal to 0, either the negative side or positive side, anywhere you take, the function goes to infinity. That is the main checking of the continuity here. So you can do this one at home, LHL. When you are doing the LHL, only thing is you have to remember that minus, all x values will be minus, including accordingly f of x also. This also become, but values will remain same. 10 to the power of n, 1000 for the same table I'm telling. For the same table, if you use minus signs you put and fx you retain minus sign, same values, and the plot looks like this. So what did you understand from this? From this we can conclude that this function is continuous in the positive direction, continuous in the negative direction, but not continuous in the sense not existing at 0. So I will write here f of x is continuous where when x is greater than 0. F of x is continuous when x is less than 0 but tends to infinity when x tends to infinity. So hope you understood this sum. So friends, I will conclude this chapter here. Hope you have followed my previous slides. You try to again see. In those slides, I told very clearly, right from the Cartesian products, then relations, then functions, and checking the continuity of functions. Nearly, I remember six videos I posted. All these videos, you please go through one after another, and then any doubts are there, you can send through through suggestions columns or through any comments columns. So now we will enter into differentiation chapter, and in my subsequent slides, I will continue the differentiation. Thank you so much.